All right, maybe we should wait a couple minutes since we got started late, give everybody a chance to transition from one activity to another. So I'm going to wait about 2 minutes, then we'll get started. There was a sign-in sheet that is available for everyone. There is one AIA continuing education credit and one USGBC continuing education credit. So. All right, well, I guess we're going to go ahead and get started. My name is David Harper, and the name of the presentation is Architects Designing Their Own Home. The name of the home is Domus Alba, and I think you'll see as we get into the presentation why the name is that. Learning objectives for today are we're going to look at the exploration of sustainable strategies in the design of a home. Importantly, the integration of sustainable strategies and architectural visual aesthetics, and the opportunities for LEED in large residences. And then lastly, the title, Architects Leading by Example. We're going to talk about that. The way this project came about is my wife and I were very involved. I'm an architect, and she is a lead consultant, a business consultant. We're very involved in the design of projects involving sustainability. And when we came upon the opportunity to design and build our own home here in Miami, we started looking at the fact that there are so many people out there that are professionals, that are in the industry, architects and others, that are promoting sustainability, building products representatives, contractors. And then when it comes time to do their own project, for some reason, the things that they are telling everyone else are so important are not necessarily so important anymore. So we thought we had an imperative as people that are promoting LEED in our professional life to actually practice it in our personal life. So the challenge, as we saw it, was to create LEED utilizing and engaging architecture. You know, there's so many LEED projects out there of the single-family homes that have involved LEED. They're so frequently, I would call them bolt-on type applications as opposed to truly integrated applications. And we don't want to do that. We wanted to demonstrate the fact that LEED is beautiful. LEED can be a very important aspect of design that should be celebrated visually, as well as in terms of its economy and all of the benefits that sustainability brings not only to society at large, but also the individuals that are involved in the LEED project. And we wanted to do it in a way that did not compromise any of the creature comforts that modern day homeowners would like to have. And importantly, we wanted to look at LEED as a way of promoting health, and the wellness aspects of LEED needed to be celebrated and engaged to the maximum extent possible. So all of those things came together, really 4 areas: design, sort of the satisfaction of human needs and the Maslow's hierarchy pyramid, the LEED for Home criteria objectives, and the Well Building Institute objectives. Good design, form follows function, an opportunity to showcase sustainability and energy saving. and to do it with a design that does not compromise itself because of the energy-saving features that are part of the home. The human needs, importantly, a sense of soul. And a sense of soul meaning needed to be an inspiring architecture, but a good neighbor. A project that fit into the community. A project that reflected the fact that we're really part of something that is bigger than us and need to be part of the community and need to give back to the community. And to also deal with our own family and creating an opportunity to bring our family together by design. Wellness, a focus on light, extensive use of light in the design, a focus on improving indoor air quality, and a focus on promoting fitness, both mind and body. LEED, all of the elements of LEED were included in the objectives. And it had to be multi-generational. Multi-generational because our family included not only college-age students, including one living at home, but also toddlers, twin toddlers, and frequently visiting relatives and in-laws. So there were a lot of different uses that the home had to accommodate, and we saw the home as a place for accommodation, not only today, but for a very, very long time into the future. So therefore it had to be adaptable to all phases of life. Good design always begins with a site, and we were very fortunate in locating a nice site in a location that some of you that are from Miami would be familiar with, along Old Cutler Road, sort of between Fairchild Tropical Gardens and the Deering Estate. We were fortunate enough to find property that backs up on a 500-acre nature preserve that includes habitat, bike path to the bay, canoe launch, and a lot of other features, both man-made and natural. And a lot of peacocks. Peacocks have frequented this property probably for 100 years, and the property had never had a home on it previously. And a lot of creatures that are even less desirable, including the nasty little no-see-ums that are called biting midges, something that had to be dealt with as part of life and as part of South Florida and as part of Miami. And other creatures as well, saltwater crocodiles. A lot of history to the site. It's located where the Red Star is. The historic Chapman Field World War I Army Air Base was located directly behind the property. And an understanding that when one builds in South Florida, sustainability means not only sustaining the future of the environment from an ecological standpoint, but also being able to sustain itself for a long period of time, to be able to stand up to the forces including those of Hurricane Andrew that completely decimated the community where this house is located some 20 years ago. Some of the results of that and the way we built back then have been changed by code and by the expansion of knowledge of time, and we wanted to go beyond that in the design of this project. So when we began to set out in the design, we were buffered on one side by pedestrian and vehicular access at our front door and a natural nature preserve bike path and park at the rear access of the property. Creating a property that fronts on both the man-made and the natural, and bringing in the outdoors into the indoors, and making the home integrated into the site, but still protected from some of the challenges of the site was very, very important. So we set out with the idea of let's provide a very logical grouping of space. Let's group the bedrooms in one area of the home. the family living areas in another, put those on both sides of the site, and create a transition space in the middle that's both indoor and outdoor, and serves as an entertaining area and receiving area for public and friends. In so doing, we were able to create a design that ultimately, through the use of zone air conditioning system and home automation, allow the house and the occupancy conditions of the house to transition in response to the solar movement of the sun passage over the home every day, so that the occupancy areas were basically in a reverse order of the movement of the sun, so that air conditioning loads could be controlled to be kept to a minimum or non-existent in the times when the solar gain was the greatest. As part of the integrated design process and as part of an accomplishment towards looking at what we could really do in the way of LEED and working towards a near net zero energy consumption model, the first thing to understand is the need to reduce energy, the need to reduce consumption, the need to reduce load. And that's done best through insulation. It's done best through good design. It involves a very close look at solar orientation. And it's done through other mechanical systems, including automated shading systems. So, as these concepts were advanced, we began to build models of the home. And again, the home was looking to not only be sustainable in terms of energy and materials, but also sustain itself in terms of being responsive in terms of the structure to some of the strongest forces of nature, including Category 5 hurricanes. The concept architecturally was that I mentioned the two frontage areas of the home, the front door, the back door. So from the front, the home was designed to be basically mostly solid with opening up to more open space, and then transition to completely integrated space at the rear, where that center portion of the home that I talked about is both an indoor and outdoor environment. Cross-sectional model begins to show how the elements of the home come together, and some of the big ideas. Big ideas being an energy tower that would do a number of things, as well as serve as an observation platform for the 500-acre nature preserve. It would also provide a support structure for solar hot water evacuation tubes, which we'll talk more about in a moment. A future wind turbine that would start out with an anemometer to be able to get some good readings to create an opportunity to examine and experiment with the use of small wind in Miami, and a photovoltaic trellis with the idea of let's get the energy devices down where they can be seen by people and be experienced as part of the aesthetics of the architecture. Built models of the home, which resulted in some tweaking of the design and improvements as a result. And in that indoor-outdoor room that we talked about, as it's seen when you enter the home, where there's basically a complete opening of space from what can be at times conditioned space, merging with the non-air conditioned space, but protected by a screen enclosure to keep out some of the no-see-ums and mosquitoes that are extremely heavy in this area. Solar trellis, as it was going in originally, again, designed to be not only an energy production device, but an aesthetic device that added significantly to the ambiance of that center space of the home. Screen enclosure, architects and designers in the last 10 or 20 years, because of the structural requirements of screen enclosures, and sort of a cultural shift away from them, have stopped using them as much as they used to. But it was very common in Miami in the 40s and 50s to use screen enclosures. So we went back and reintroduced the concept of the screen enclosure as a completely integrated element that was seamlessly tied to the structure and the form of the house. The tower we spoke of earlier provided a multiplicity of functions. It also served as a platform for a lighting playfield, the platform for the support of the solar hot water evacuation tubes, the observation platform, and the platform for the future wind turbine. The stairway shown here, and you can see one of the banks of 10 solar hot water evacuation tubes. So, the commitment to walk the talk, we felt was an experiment not only in doing everything we knew would work, but kind of stretching the envelope to do some things that were a bit experimental, so that we're truly creating a living, learning laboratory. Some of the energy saving strategies and lead strategies for materials involve all the elements that you see here. Long durability, and a focus on elements that were designed to not only towards LEED, but designed towards wellness and comfort, such as humidity control. Strong dedication towards humidity control, the dedication of fresh air envelope opportunities, fresh air requirements and introduction into the home. On-demand hot water loop, coupled with the solar hot water, provides all the needs of the home. And of course, the need to protect the home from hurricanes. 100% concrete structure is provided through the use of 8 to 12-inch concrete block with substantial areas of poured reinforced concrete along the center sections of the home where you see those square windows. We decided to up the wind design, even though technically we could have been by code at a design speed of slightly less than 180 miles per hour. We decided to go ahead and up the speed to 180 miles an hour to make sure that the home would be designed to withstand the kind of destruction that took place during Hurricane Andrew on this community. So, the separate living zones, the live zone, the great room, the relaxed zone, combine together to create a clearly organized architecture that provided a sense of scale and a sense of comfort and function for the users of the home and for our family. Some people think that an important strategy in LEED is to reduce the amount of air conditioning. Our approach was, let's reduce the usage of air conditioning by having it very precisely controlled. So, contrary to what some might think, we have actually 5 air conditioners in the home. However, seldom are there more than 1 or 2 running at a given time because of the precise use of the application of air conditioning, even on the hottest days, only focused on the areas of the home that are occupied and the areas where the solar gain is actually taking place. And as a result, a significant energy savings is achieved. The ability to compartmentalize areas of the home by use of sliding partitions, such as that 11-foot sliding barn door you see in the photograph on the right-hand side. The use of fans, including the 10-foot big-ass fan. And of course, the solar hot water. I mentioned dealing with some first-time use of certain products and technologies. This was the first use of the GLE solar hot water evacuation tubes in the state of Florida, so we had to get the Florida Solar Energy Center to approve the use of these panels before they could be installed. We learned some things in the process of doing that I'll speak about more in a moment, because anytime you introduce innovative technology into the residential construction market, there's going to be some challenges and there's going to be some learning curve. This is the design of the solar hot water system. There's actually 2 separate systems. It's a split system. And one of the biggest concerns as we got into this was the concern of overheating of the water. The concern that we actually might be producing steam. So we had to have 2 hot water tanks, more so to negate the possibility of overheating than it was to actually create reserve capacity. So we have that. We have the expansion tanks, of course, and we also have blowout valves located on the tower with a pipe down into the ground, into a dry well system, in case the the system overheats. So there's 2 complete solar hot water systems. The house is split into 2 zones, as I said, actually 3 zones. So the living zone on one side of the house, the east side, has a solar hot water system, and the sleeping zone on the west side has a solar hot water system, and in the center is actually just 1 bathroom in that area that's fed from one of the sides. These are some of the mechanical areas of the home and some of the in construction, in progress installation of the solar hot water system. The solar PV system, 9.88 kW. System was designed, as I stated earlier, to be such that it was visible from the underside as well as from the top. So you can transmit light through the panels, and it provides not only a very nice sort of muted shading device along the back edge of the pool, but it also at nighttime provides an opportunity for the LED lights that are in the spillover basin of the swimming pool to be cascading off the bottom of those panels, and creates a really interesting aesthetic effect as well. Bamboo was used throughout the home for all of the woodwork throughout the home, in the kitchen, in the buffet areas, all appliances, of course, Energy Star. Every single light in the house is an LED light, or in a few instances, fluorescent. All fixtures, low flow, generally 1.5 gallons per minute, on sinks and showers. Toilets, dual flush, either 0.8 or 1 and 2/8. Landscaping and drivable surfaces. For the drivable surface, we utilize the grass paved 2 system, which, interestingly enough, we had a hard time getting our certificate of occupancy because the building inspector came out and said, well, we won't approve a certificate of occupancy if you don't have a driveway. We said, well, we have a driveway. No, I don't see a driveway. Well, it's the grass. And unlike some drivable grass surfaces where you have sort of a honeycomb block system of concrete with little sprigs of grass coming up through it, this system is completely invisible, completely submerged below the grass level, so that it's not seen at all. The fans, again, provide a significant reduction in energy and are used throughout the home. Bamboo, again, and all paints and other sealants and materials in the home, the zero off-gassing. I might also mention that the operations of the home, my wife has been insistent upon the fact that we'll have no pesticides in the home. There's never been any product pesticides. We're using natural pesticide products that she's done a lot of research on, and I will tell you, we've never seen but one little tiny small bush in living in the home for 1 year. So it's amazing in South Florida what can be accomplished with a commitment to LEED and a commitment to sustainability of product usage. Strengthened glazing, ended up with triple pane glazing, essentially 2 laminated glass and then an airspace and an additional sacrificial panel to create maximum energy saving in order to meet the highest standards of LEED. And we'll talk about that a little bit in a moment, because one of the real challenges of doing a home like this in South Florida is the fact, or in any area really, are the penalty points that's applied through the LEED process for doing a home that's a larger home as this home was and is. Home automation is used extensively for HVAC, lighting. All window shades in the house are controlled electronically and can be responsive to solar movement, time of day, programmed. Security systems, the audio-visual systems, the photovoltaic systems are all integrated into a Control 4-based home automation system. So, some of the challenges, that home automation system, getting good coordination between the electrical contractors and the low voltage contractors proved to be a big challenge, but one that we dealt with and successfully accomplished, even though even to this day there are certain bugs in software that from time to time prove annoying, but it's part of the price you have to pay when you try to do something that's a little bit more beyond the norm. Thermal Chromex, the entire house doesn't have any paint. We used a hydraulic limestone material that's applied to the outside of the house, that's applied over concrete block and concrete masonry, or concrete, cast-in-place concrete, never requires painting, has really good vapor permeability, it's not resistant to, or it doesn't promote shrinkage cracks, resistant to salt, and has a very long life expectancy. And it's proved to be very successful, and something that, to our knowledge, had certainly never been used on a home in the state of Florida, and perhaps few, if any, homes in North America. But, again, you do something different, you pay a price. So, finding a contractor that could apply the material proved very challenging. And another challenge was that when we did get the contractor, we had to bring in resources from out of town, expertise to apply this product. It turns out that the standard of quality that is normal to the industry in South Florida in terms of the way concrete block is laid creates a level of irregularities that created the need for the application of a greater amount of product than was estimated. So as we're going through the application process, we're constantly being told, we need more product, and we ended up having to skim coat the home in a mortar mix in certain areas in order to smooth out some of those imperfections in the block. And believe me, as an architect and a person who's been involved in building construction for my entire life, those things will just drive you nuts. But I'm told that the quality of the block work on this house was probably superior to many. But lesson learned is that if you're going to use a product like this, there's going to have to be a far higher standard of expectation in terms of block quality. As we were finishing the home, we decided to go all the way and make sure that the metal areas and aluminum areas, such as this very significantly tall spiral stairway, were protected along with the rest of the home from lightning strikes, which are so prevalent in the area. And as part of that, with an extensive home automation system, the need for a whole house of surge protection system was found to be important as well. Insulation, the walls, achieving an insulation requirement basically involved putting foil back tape on all the studs so that there was no thermal transfer through the block into the interior of the home, and a 1.5-inch thick R10 closed cell insulation in between the studs, which, as we know, is a lot thicker than is normally applied in residential construction, and then the use of isonine under a structural roof deck, giving us an R30. And then the important PERS rating. Many of you probably know what PERS is, but for some that may not, it's an index of scoring homes' energy performance, and the lower the number, the better the score. So basically a score of 100 PERS would be the score that a home of today, meaning all current code, would meet. So this home came in at essentially 1/3 the energy consumption of a home that would meet all current codes. And as a result, the reference home of similar size by computer modeling was determined to create an energy consumption for electricity of about $5,100 a year, and the energy consumption of this home was $2,094. So to put that, here are some of the numbers behind it. And to put it in perspective, an average size home in Florida is 1,668 square feet. This home was 7,000 square feet, or 4.5 to 8 times larger. The energy consumption of that 1,668 square foot home, based on statistical data from the U.S. government, is about $2,000 per year in electrical consumption. And the energy consumption of this home, 2,094. So it's 4% more energy consumption, but 4.5 times larger. So the message here, and it was part of the objective of my family, was to show that if someone's going to build a larger home, you don't need to take any more share of your energy than the home that is the typical size home in the state. And I think we did that. Blower door testing is a simulation of how tight the home is. I think there might be a little video here, but maybe it won't run, I'm not sure. So why don't we go on to the next one. The American Institute of Architects posed a challenge to its membership called the 2030 Commitment. And the commitment was, we want the architecture profession to promote the reduction of energy consumption by the year 2030 by 60%. The Domus Alba certified HERS rating of 33, including an annual energy consumption of 30 cents per square foot, surpasses that challenge today. So we were pleased to accomplish that. Our team of contractors and engineers are identified here. Our contractor was Torrey Construction of Miami, Mario Suarez, the structural engineer, Matern Engineering, Mechanical, Electrical, Plumbing out of Orlando, Biscayne Engineering, Civil, and Rosenberg Gardner Landscape. And I was the architect. Some of the companies that have worked with us closely and been instrumental in producing some of the results include the ones shown here, and a couple of them, or three of them actually, specifically CGI windows, big ass fans, and thermal chromex, are using the home in some of their national publicity, demonstrating and showcasing the fact that a home like this could be created. Construction effort broke ground in July of 2013. You can see my wife and our littlest kids there in the middle. Concrete roof, a lot of concrete. Work proceeding on the interior. And then the result, again, that drivable grass surface has proved interesting, because a lot of people are afraid to drive on it, and we still are in need of a sign that welcomes people to drive on our grass driveway. Otherwise, they stay out of the street. So it's a matter of education. The lighting is very, very important in the home. The ability to leave all of the doors open for so much of the time to create that indoor-outdoor feeling that is so welcome in South Florida, particularly at this time of year. It's just an amazing opportunity. Some of the pictures. Again, the solar trellis that not only produces electricity, but we believe is a significant positive, makes a significant positive contribution to the aesthetics of the home, and also the screening. As you can see in this picture, those screens are electronically operable, so they open up. So at times of the year like this, when those little no-see-em creatures are not active, you can open the whole thing up and enjoy the outdoors freely. At night, it's a great place to be. Solar trellis, pool, and view into the center area of the home, which we call the great room, that room that seldom gets air conditioned because of the airflow and the fact that it's really a transition space from the family living space on one side of the home to the bedroom and sleeping space on the other side of the home. Some of the accomplishments, to our knowledge, this is the first home of this size in South Florida to ever achieve a LEED Gold certification. In order to do that, we had to overcome a negative penalty points of 16.5 points. So in other words, when we started the LEED process, we started at negative 16.5. And the reason for that, for some of you that don't know about LEED for homes, is the fact that there is a desire in LEED for homes to promote smaller homes because of that energy, the assumption that the energy consumption will be so much higher. So in order to get our energy consumption the same as a typical size home, we had to be essentially 4 or 5 times more energy efficient. So even with that, we were able to do it. We got the HERS rating of 33, the energy consumption of 30 cents per square foot, and we met the AIA challenge. The home has been featured, was awarded by Habitation Magazine in the Dream Home Awards before it was even completed. The Gala Verde, the United States Green Building Code, United States Green Building Council, South Florida chapter is the Home of the Year. It was awarded in November as the most outstanding home of the year. A proclamation from our Village of Pinecrest as being the first LEED Gold home, or LEED home of any kind in the Village of Pinecrest, and the current edition of Florida Design Magazine has the home featured as the centerfold in the magazine. It's on the cover of the Florida Caribbean Architect, and it's in Pinecrest Magazine, which is coming out next week. So fortunately, the home, from a standpoint of trying to serve as a model for what can be accomplished, has gotten good publicity and has been very, very embraced. One of the things that my wife and I sought in designing this home was, as we looked around our community, we said, can we prioritize sustainability and wellness and not spend any more money on building a home than everybody else is spending because of the accoutrements that so many people put into their homes. And we believe we clearly accomplished that. This home had the same budget as every other home of a similar size that's going up in our community, yet we accomplished some things in terms of the benefits to our family and the benefits to the broader society, we think, are important to us, and hopefully can become more important to others as we go forward. So does an architect who advocates sustainability have a responsibility of meeting a standard in the design of their own work? We believe so, and we hope we have done that. And a little funny cartoon here about sustainability and the environment. And my wife has a lot of allergies, and a lot of the things in LEED, sometimes, if it's not well handled, can work adversely, to certain aspects of human comfort. And we pledged not to do that. We think we accomplished it and actually created a home that benefits health and doesn't add to the irritating things that can sometimes plague your life. So with that, I want to thank all of you, and thank you for being part of the President's presentation today, and say, that one home like this really can't make a difference in the world, but by educating people and creating a momentum to a commitment to sustainability, by everybody improving the energy consumption of their own home, even by a little bit, it goes a long way. And that's what we would advocate, not only for design of new homes, but for renovation of homes and for people that are looking to simply do a little bit more with what they have. So thank you very much. And with that, I'll open up for questions.
What was the cost per square foot?
The cost per square foot was about $200 a square foot. Yes.
Was there a screen or something underneath the solar panels?
No, the solar panels are all sealed. All the gaskets between them, again, getting back to the challenge of doing something that had not been done before, getting those solar panels, we used a Florian mounting system, butted them together, gasketed them, and then sealed them.
So there's no way
it's airtight. Well, I wouldn't say airtight. Let me retract that. It's quite tight to the point that almost no water comes through but maybe a tiny bit of water in a big rim.
Well, the reason I was asking, it looked like you had some sort of set of sliders on the other side or something that you closed off the space for the bugs or whatever in the pool area. Is that?
Well, there's operable screens on the back side of those panels, and there's screening that comes down to the top of those panels. So there's a complete envelope of screen enclosure that's around the pool, of which the panels themselves form one surface of that perimeter enclosure.